Hi, our name are Nidhi Shahida and Nurul Shafiqah Nasuha. In this video, we want to share how we would design and manage a mathematics classroom that helps students understand, participate, make mistakes safely and grow using topic of linear equation for Form 1 student. Section 1 is introduction of topic and learners. We have decided to study linear equation, specifically how to solve basic equation like x plus y equal to 12. We picture a class of 30 or so pupils in Form 1 who are learning algebra for that first time. For us, this is not just a hypothetical lesson. When we tutor science part-time, we saw the same pattern, which is some students could handle number and familiar with confidence, but even if the computation behind was straightforward, they stopped the instant a symbol stood in for an unknown value. We envision the similar mix in this Form 1 class, which is students who are comfortable with the number but are unfamiliar with algebra symbol. A couple who require something tangible to grasp before the abstraction makes sense, and one or two who have minor math anxiety since they had trouble with fraction the previous year. Almost every choice we make in this course is influenced by the combination. Section 2 is learning theory. For topic 1, we are using two theory. The primary one is cognitive constructivism. This is founded on Piaget, theory that pupils construct their own knowledge from concentrated experience before they can cope with abstract idea. Form 1 pupils are still transitioning from concentrate to abstract thinking. Thus, instead of writing the equation x plus 1 equal to 12 on the board, we would start with a physical balance scale, actual or drawn, with one side having an unknown which plus 5 blocks and the other side having 12 blocks. Students basically see that whatever you do to one side, you must do to other, which is basically the fundamental principle behind solving equation. We also want to include a little bit of behaviorism too, since even all students understand the concept, they still need repeated, controlled practice to become fluent. Quick drill with prompted praise or correction help them develop that muscle memory for the step. So Piaget provides the why and later Skinner practice the how quickly and confidentially. But we know these two theories are not good fit. Constructivism let kids acquire knowledge through their own struggle. Behaviorism relies on us guiding the response through repetition and reinforcement. If we lean too hard on drilling too early, we risk on making the same making the balance scale was intended to grip. And students go back to memorize this step without meaning. So the order of event is more important than the theory themselves, which is concept first, drill only when the why is secure, never the other way around. Section 3 is School for Teaching Mathematics. From the topic 2, we want our teaching to support concepts through understanding and procedural fluency, not just one or the other. If we only practice the step, pupils can solve x plus y equal to 12 properly, but they have no clue why the strategy works. They get lost as soon as the question look a bit different. So the balance scale provides the notion equality must be preserved, and guidance practice develop the fluency to apply it swiftly and properly. We also want to protect student growth mindset here, because algebra is often where students start saying, I'm just not a math person. So we plan to actively prize effort and reasoning, not just correct answer, and to treat a wrong first attempt as useful information rather than fail.
Okay, for the next slide, which is section 4, instructional planning and differentiation. We would structure the lesson of the 5E model from topic 3. Okay, the first one is engage. We start with a short real-life situation. For example, a food stall sells a set meal, but we only tell them the total price and the price of the drink. They have to work out the price of the meal itself. Is x plus 5 equals 12 in disguise and gets them thinking before any algebra notation search. Okay, the second is explore. Students partner up to model the problem with a simple drawing of a pen's balance and counters and to solve it physically before we'll tell them the method. Okay, the third one is explain. We bring the class together and link the students' findings to the former idea of doing the same operation to both sides and introduce the algebraic notation, which is x plus 5 equal 12 to x equal 12 minus 5. Okay, the next is elaborate. In mixed ability pairs, students apply the method to 2 or 3 new real-life problems which is working out bus fare or pocket money scenarios. And the last one is evaluate. One short exit ticket is one equation to solve and one sentence explaining why they think that. For differentiation, we would give 3 levels of practice questions, which is practice, stretch, and challenge, so that the struggling learners continue to work with consecrate balance diagrams just a little longer, and confident students move more quickly to 2-step equations. We also put a stronger student with one who needs support during explore, and so peer explanation accomplishes some of the teaching for us. We will grant you that comes with a price. For example, a full on concrete. Discovery first 5E seasons takes a lot longer than just showing the stage and moving on. And with a syllabus to cover, that time has to come from some place. We think that the slower pace is worth the depth for a truly novel and abstract idea like as denoting an unknown. But for issues students have some prior exposure to, we would shorten explore and spend more time in elaborate. So, the 5E structure isn't something that we do the same way every lesson. It's a choice we make based on how unfamiliar the concept is. The next slide, which is section 5, classroom management and active participation. Okay, drawing on topic 4, for this to work, students need to feel safe enough to try and get it wrong and try again out loud. So, in the first week, we do co-design classroom norms with kids. Simple things like it's okay to make mistake here and listen before you disagree, rather than just imposing regulations. If a pair goes off task during the season, we wouldn't call them out in front of everyone, but we would offer a modest, low-key indication such as going closer, a fast non-verbal communication initially. And in dual work, we would allocate defined duties, which is one student manipulates the balancing model, the other notes the steps, so that both are accountable and engaged rather than one doing all the work. The next slide is section 6, formative assessment and feedback. Going back to topic 1's idea of formative assessment, if we wanted to verify understanding as the season happened, not just at the end, we would utilize little whiteboards in the explore and explain phases. We pose a brief equation, which is the students write their answer and hold it up, and we can see straight away who is still lost. Our feedback in that instance will be precise, not just wrong, try again. If a student writes x equals 17 for x plus 5 equals 12, we do remark, you added 5 when you should have subtracted it. Look at what operation is happening to x, and then do the reverse to both sides. That tells them exactly what they did wrong and what they need to do next, which is much more useful than just marking it. The last slide, which is section 7, final personal reflection. From me, I am Nurul Syafiqah Nasuha. My road into teaching hasn't been the standard one. I came from a sports studies background with an internship at a state sports unit and part-time science tutoring. What I have learned from this task is that a lot of what I already knew from coaching applies directly to teaching mathematics, which is you don't hand someone the finished technique. You let them try, feel where it goes wrong, and fix it with them. So, the kind of teacher I want to become is one who treats a wrong answer as information to work with, not a failure. The same way a coach treats a missed attempt. But I have to question my own assumption here. I'm assuming every Form 1 student will find a physical balance scale model helpful rather than childish. When a 13-year-old wanted...
Section 7 is a final personal reflection. I learned something and it's really made me think about teaching mathematics. Teaching mathematics is not about telling students formula. It is also about helping them understand the concept in a way to make sense to them. I want to be a mathematics teacher who's passionate, supportive, and creative. I want my students to really enjoy learning mathematics. My idea of teaching mathematics has changed a lot. Now I think it's really important for students to be actively involved in the learning process and to participate in class. Teaching mathematics is not about standing in front of the classroom and talking. One thing that might be difficult for me is teaching students who learn in different ways. Mathematics students are all different, they need different kind of help. I will deal with this by trying different way of teaching and giving my students the encouragement they need. I will also give them help when they need it. I think this will make a difference for my mathematics student.